Hi everyone, today we are going to learn virtual functions. So before going to learn virtual functions, I repeat the yesterday class. So then these are the contents in our syllabus, in 4th unit syllabus. Pointers and binding polymorphism and virtual functions. The first topic is over pointers. Second topic is also over yesterday class. Then today we are going to learn virtual functions. So in the pointers, we know what is a pointer, then what are the features of pointers, then how to declare a pointer, then how to declare a class variable to pointer, and how to define an object, pointer objects, this pointer, and pointer to derived classes and base classes. Okay, in the first class, we discussed all these contents. The second class, binding polymorphism and virtual functions. Before going to learn virtual functions, we discussed binding polymorphisms. So what is polymorphism? Simply, what are the types of polymorphisms? Then how the polymorphisms executed in our C++ language already we learned. Clear? Then here simply pointers. Simple pointer. This is the definition of pointer. So what is a pointer? A pointer is a memory variable that holds the address of the another variable. Clear all of you? Then this is the general syntax of the pointer. A type asterisk variable name. Your type is an integer, maybe integer, float, character, double, or class, whatever it may be. Okay. Then the variable name that is the given by us, that is the user defined name, asterisk prefixed an asterisk. Clear? So how to indicate this is a pointer variable or not? Is it pointer or not? Simply a variable prefixed an asterisk, that is called a pointer variable. That indicates. Clear all of you? Then the general examples: integer x asterisk x, float asterisk f, character asterisk c. Then x, f, c. These three are the pointer variables. X is an integer variable. Float type is so f type data type is float. Then c data type is character. Clear, all of you? Then this is an example of pointer variable. Then what are the features of pointer variables? Then these are all the features of pointer variables. Then pointer to classes. How to define a pointer to class? For example, this is a class. The class name is called man. Your man m. So man asterisk ptr. Then m is a general object. Then ptr is a pointer object. Then where ptr equal to ampersand m. Then so simply display name and yes. Your ptr to name and ptr to yes, simply. Okay. Then your ptr is a pointer variable to define class. Your man is a class name. Then m is a variable. Your man is a class name. ptr is a pointer variable, pointer object. Simply your class object, class object. The type is class. Object name is ptr. That is a pointer variable. Clear all of you? Then the next one is pointer to object. Pointer to object. Then here bill asterisk b ptr equal to ampersand b. Here pointer to object. This is same as the previous example. Clear all of you? Then the next one is this pointer. We are using this pointer. This pointer is used to show the current object. Clear all of you? Okay. Then this is this pointer. This is an example for this pointer. Okay. Next one is pointer to derived class and base classes. Then this is a base class. Then this is a derived class. Then pointer base class object. Then the next one is derived class object. Clear? All of you, where BP equal to ampersand B. Ampersand B. BP is a base class object. Ampersand B. B is a derived class object. Derived class object address assigned into base class pointer. Clear all of you? Yes. Next, polymorphism. We know there are two types of polymorphism. Before going to discuss polymorphisms, what is polymorphism? Polymorphism is a Greek word. Clear? Greek word. Poly means many, morph means forms. Clear? Polymorphism means many forms. There are two types of polymorphisms. The first one is compile time polymorphism and the second one is runtime polymorphism. What are the changes occur in the compilation time? That is called compile time polymorphism. Compile time polymorphisms are also known as early binding, okay, or static binding. Runtime polymorphism is also known as what are the changes occur at execution time. So that is called a runtime polymorphism. Then runtime polymorphism is also known as late binding or dynamic binding. Late binding or dynamic binding. Clear? So what are the examples of compile time polymorphism? Function overloading and operator overloading. These two are the examples of compile time polymorphism. What are the examples of runtime polymorphism? Virtual functions, like using pointers. Clear? Virtual functions, runtime polymorphisms. So last class we discussed. Okay, then binding. What is binding? Binding refers to the process that is used for converting functions and variables into machine language. Clear? So converting functions and variables into machine language, that is called binding. How many types of bindings? There are two types of bindings, two types of polymorphisms. There are two types of bindings. The first one is called static binding. Second one is called dynamic binding. Static binding is also known as early binding. Dynamic binding is also known as late binding. Clear? Then the static binding and dynamic binding. This is an example for dynamic binding. So static binding, the information is known to the compiler at the compile time. What are the changes occur at compilation time? That is called compile time polymorphism or static binding or early binding. Clear, all of you? Therefore, compiler is able to select the appropriate function for a particular call at the compile time itself. Clear? So it is called early binding or compile time binding or static binding. Clear? So then the dynamic binding, the appropriate version of function will be invoked at runtime. So what are the changes occurred at runtime? So that is called dynamic binding or late binding or runtime polymorphism. Clear? Since the function is linked with a particular class, much later after the compilation, this process is termed as late binding. Clear, all of you? So then this is an example for dynamic binding. So dynamic binding here point the execution time. So the address assigned into BPTR, then BPTR dot show. So it will execute the first one base class member function and it can execute the next one derived class member function. Clear, all of you? Then the next one, base and derived class objects. Simply how to create a base object and how to create a derived class object. How to assign the derived class object to the base class. Then in inheritance, the derived class inherits all the properties of the base class. So pointers, so that base class objects are type compatible with the pointer to derived class objects. So a base class pointer can point to the object of the derived class. Clear? A base class pointer can point to the object of the derived class. But a pointer to the derived class object cannot be pointed to the object of the base class. Remember this point, all of you. So a base class pointer can point to the object of the derived class. But a pointer to the derived class object cannot point to the object of the base class. Remember. Okay, all of you. So come here, see the diagram, all of you. This is a base class pointer, then base class object. So simply it can show the base class object. Then the base class pointer show the derived class object. But derived class object shows the derived class pointer only, but not the base class pointer. Remember, all of you. Clear? So then the next one, this is an example for base class objects. Okay. The next one is virtual functions. This is the most important functions already discussed in third unit last concept, virtual functions. So how to form a question? How to form a question? What is virtual function? What are its rules? Explain with example. Clear, all of you? What is a virtual function? Then what are its rules? Explain with an example. So simply R, explain about runtime polymorphism with an example. Remember, runtime polymorphism or virtual function, both are same. Okay, all of you? So simply, what is virtual function? How to form a question? So most important question I will give in mid examination also. Then maximum they will ask in end examination. Okay. So then simply, what is a virtual function? What are its rules? Explain with an example. Explain about runtime polymorphism with an example. Clear? In inheritance, the same function name, all of you remember, in inheritance, the same function name in both base and derived classes. The function in base class is declared as virtual using virtual keyword, precedes its normal declaration, Clear? Normal declaration. When a function is made virtual, C++ determines which function is to be used at runtime based on the type of object pointed by the base pointer. Clear? C++ determines which function is to be used at runtime. So here simply define the base class member function virtually. No need to use the virtual keyword in derived class member function. So at the runtime, which function is executed first, then which function is executed next. Clear? Based on the calling, it will execute the virtual functions. Clear? So it in C++ determines which function is to be used at runtime based on the type of object pointed by the base pointer rather than the type of the pointer. Clear, all of you? Then, so these are the rules for virtual functions. So first rule is the virtual function must be member of some class. Clear, all of you? So the virtual function must be a member function in a class. They can't be static member functions. Okay, so they cannot be static member functions. They are accessed by using object pointers. Okay, a virtual function can be friend of another class. Constructors can't be virtual. Destructors can be declared as virtual. Clear, all of you? Constructor functions cannot be virtual, but destructor functions can be declared as virtual. The prototypes of base class and derived class must be same. Clear? So for example, in the base class virtual function prototype is integer, we should maintain the same prototype in the derived class also. Clear? The base class member function name and the derived class member function name both are same. Clear? Then the next one, the base class prototype return type integer, character, float, double, or class, whatever it may be. And the derived class prototype is also same. Okay, all of you? Then the operator overloading is also supports the virtual mechanism. Operator overloading is also supports the virtual mechanisms. So if a base class contains virtual function and if the same function is not redefined in a derived classes in such as the base class function is invoked. Clear? If a base class contains virtual functions and if the same function is not redefined in derived classes. Clear? So in such a case, the base class function is invoked. So these are the rules for while using virtual functions. We should follow these rules. Clear, all of you? Then, so example program, virtual. Out of open, then V for virtual. Virtual F5. So this is an example program for virtual functions in inheritance concepts in polymorphism, simply in polymorphism. Then no errors and no warnings, all of you. Then your class, base is the name of the class. Clear? This is the base class. So then your pub void display, this is a general method in the base class. Then this is a virtual method, void show. Virtual is a keyword. So void show. Clear, all of you? Void show. Then this is the virtual method or virtual member function in base class. Then come here in the derived class. In the derived class, void show, I didn't mention virtual keyword in the derived class. Clear? But the function names are same in a derived and base class. Void show and void show. Clear? But in the base class method is virtual, but in the derived class method is not a virtual. Clear all of you? I didn't use virtual keyword in the derived class. Then the main function, your base object is B, base class object is B, derived class object is D, then base class BPTR is a pointer variable of the base class. Here B is a BPTR equal to ampersand B, the derived class of the base class object address assign into pointer variable, then BPTR to disp, BPTR to disp. Then which function will execute first? Then here simply control F9. So this is an output, Alt F5. Then the base class display function executed first, and the second one base class show function executed second. Then the next one is base class display function is executed, and the final one base class derived class show function will execute. Clear all of you? So then simply here BPTR display, the base class member function display function will execute. Then the next calling BPTR to show, then the control go to base class virtual function is executed. Clear? Virtual function is executed. Why? Here BPTR is a base class pointer. BPTR is a base class pointer. Then I used a virtual keyword. That's why it will execute the control go to the base class member function first. Then in this situation, in this case, the derived class member function executed. Clear? Then BPTR to display and BPTR to show, finally return 0. Clear all of you? Then this is the virtual keyword here prefixed with the normal function. Clear? So here virtual is a keyword. So why show function is a general method in this class. Clear all of you? General member function in this class. So then while using virtual keyword, this is virtual member function. So here base class member function name and derived class member function name are the same. Clear all of you? Then the next one is pure virtual functions. Pure virtual functions. Simply pure virtual functions. What is pure virtual function? So how to form a question? How to form a question? So what is a pure virtual function? What is its use? How to form a question in end examination? What is a pure virtual function? What is its use? What is its use? Pure virtual functions are also called do nothing functions. So defined but never used. That is the meaning of pure virtual functions. Pure virtual functions are also called do nothing, defined but never used. Okay, virtual functions are defined but never used. Then the next one, there are always virtual functions. These are always virtual functions. Virtual functions are defined with a null body and they may be overridden by derived classes. Virtual functions are defined with a null body and they may be overridden by derived classes. Clear? Pure virtual functions are defined as follows. Here virtual void display equal to 0. Why? So the definition itself, pure virtual functions are also called do nothing functions. Simply 0 is assigned to the pure virtual function. There are always these are always virtual functions. Virtual functions are defined with a null body and they may be overridden by derived classes. Clear? Overridden by derived classes. Pure virtual functions are defined as follows. This is the general syntax of the virtual function here. Pure virtual function, virtual void display equal to 0. That is null body. After declaration of a pure virtual function in a class, the class becomes abstract class. The class becomes abstract class and are not able to declare an object, and are not able to declare an object. Clear? These classes derived from the pure abstract classes are required to redeclare the pure virtual functions. All other derived classes without pure virtual functions are called concrete classes. Assessment question, assessment bit. All other derived classes without pure virtual functions are called concrete classes. Clear? Concrete classes. These classes can be used to create the object. So in this example, in this example, pure virtual functions. So pure virtual functions, this is the example program for pure virtual functions. Here this is the first class, this is the second class. Here simply virtual wide display. This is defined but never used in the program. Clear all of you? So this is virtual wide display equal to 0. This is pure virtual function. All of you. Then come here. So class second, public first, integer day, public second. This is a constructor method in the class second. Then the next one is wide display. So then display b value and d value. Then come here in this main function. Here first asterisk p, where p is a first class object. Second s, p equal to ampersand s. Then p2 display data. P2 display method. Simply it can call the display method. Here, which is the display method? This method will invoke. This method will execute. All of you. So here p is a base class object, but it will execute the derived class method. Simply display b value and d value. Clear all of you? So then here in the pure virtual functions, simply defined. So the body of the pure virtual function is null. Okay, all of you. The body of the pure virtual function is null. Clear? Then so compile, no errors and no warnings. Then control F9 for execution. Then alt F5 for output. In the simply here b equal to 10 and d equal to 20. This is an output of the pure virtual functions. Clear all of you? Then here, what is an advantage of pure virtual functions? Simply, which is the pure virtual function? It will not execute, but it will not execute the derived class member function. Clear all of you? So why? So this is a pure virtual function. The body is null. Then there is no statement available in the pure virtual functions. But in the derived class display function contains some statements. Those statements will executing. Clear? While calling base class object. Clear all of you? Base class object through display function. Simply it will call this function only. It will display the b value and d value. Clear all of you? So simply this is an example. Okay, all of you, control F9. Then output is b value is 20 and d value equal to 20. You consider last values, all of you. Please consider last values. Then the next one is abstract classes. Sometimes implementation of all functions cannot be provided in a base class because we don't know the implementation. Such a class is called abstract class. Class is defined, but we never used. Already discussed in the third unit. All of you, third unit, last topic. Abstract classes. Okay, abstract classes. Class is defined, we never use it. Clear? Sometimes implementation of all functions cannot be provided in the base class because we don't know the implementation. Such a class is called abstract classes. So defined but never used. The base class that has one or more pure virtual function is called the abstract base class. The base class that has one or more pure virtual function is called the abstract base class. These classes designed as a framework or layout for derived classes. Okay, these classes, which classes? Pure virtual base classes are designed for framework or layout for derived classes. Clear? We cannot create objects of abstract classes. We cannot create objects of abstract classes. Already we learned it in the third unit last topic. So now, so in the fourth unit also discussing. Clear? An abstract base class cannot be instantiated, that is an object of its type cannot be defined, but a pointer to an abstract class can be defined. The example of abstract classes, might have open abstract classes. This is an example program for abstract base classes. Simply the class shape, this is an abstract class, abstract base class. Here defined all the functions, methods, members and member variables. Clear? Methods and members. L is a member of this shape class. Then get data and float area. This is a pure virtual function defined, but I never created an object here. So then, is there any first class is there? Shape class is there? No. Clear? So simply, what is abstract class? Abstract class is defined, but we never use it. Clear all of you? Abstract class is defined, but we never use it. That is called abstract classes. So in this example, the shape is an abstract class. So here defined all the variables and member functions, but I never created an object. I didn't create an object in this main function. A square is a derived class. Square is a derived class. Simply this is a square. Square is a derived class. Circle is also derived class. I created square class object and a derived class object, circle class object. Then simply s dot get data, square dot get data and square class dot area. Then the next one circle dot area. Clear all of you? This is a square class object. This is also square class object. Then this is the circle dot circle class object. Clear all of you? Then I am calling square get data method. Then I am calling square area method. Then I am calling circle area method. But I never call the base class methods. Clear all of you? Then the class is defined. We never use it. I didn't create an object. This type of classes are called abstract classes. Clear all of you? Okay, then for example in a train, then there is a last compartment, guard compartment. That is also compartment, but the passengers will not allow into the guard compartment. Clear all of you? Then there is a train. The last compartment is the guard compartment. The passengers will not allow. Clear? So here also the same thing. Base class is defined but never used. Clear all of you? This is called abstract base class. Then the next concept is, so V table and VPTR, virtual table and virtual PTR. Okay, we know binding. Two types of binding, static binding and dynamic binding. V table, memory tables here. Binding means linking the function call and real function. Linking the function call and real function. Binding can be done either compile time or runtime. Clear? There are two types of bindings, static binding and dynamic binding. Static binding means compile time. Then the dynamic binding means runtime. Clear? Here virtual keyword prevents the compiler from performing compile time binding, and the binding is postponed until program execution. Clear? So then, so when an object of base or derived class is created, a void pointer is inserted in the virtual table. The virtual pointer points to the virtual table. The virtual table is used to perform late binding. Clear? The virtual table is used to perform late binding. Small example. So in a railway station, there are different compartments are there. Okay. So those are all available in the loco shed. So then the officials collecting each compartment from loco shed, then they will collect and combine, simply arrange the links between compartments. So that is called addresses. So from one address assign into another compartment, simply arrange the links between compartments. Clear, all of you? So here in the program execution time and compilation time, the bondings, arranging addresses from calling function to called function. Then what are the members? Actual members and formal members. Clear? Actual members and dummy members or formal members. Arranging the addresses. So those addresses stored in a virtual tables. Clear, all of you? So like here compartments in the train. Before going to run the train, simply arrange the links between compartments. After arrange the links between compartments, then move the train. Otherwise, only engine will move, then compartments will not move. Clear, all of you? Then here also the same. Before executing the program, simply we can arrange the compiler can arrange the addresses. Okay. Simply arrange the addresses. Those addresses stored in a V table, virtual tables. For late binding, the compiler establishes V table. Clear? For class and its derived classes having virtual functions. If no function is redefined in the derived class that is defined as virtual in the base class, the compiler takes the address of the base class function. The virtual pointer should be initialized with the beginning address of the relevant virtual table. For example, when there is a linked list, so the first one is header node, then the next one is new node, the header node connecting to the new node. So the new node is the current node. Again, I want to create a new node. Then a new node to next equal to current node. Current node to next equal to new node. Again, I want to create a new node. Again, current node to next equal to new node. Then here links arranging. Clear, all of you? Then here also the same. If no function is redefined in the derived class, that is defined as virtual in the base class, the compiler takes the addresses of the base class function. The VPTR should be initialized with the beginning address of the relevant virtual table. In the linked list, the first address, that is header part. Clear? So then based on the header part, we will move from one by one elements. Clear? Here also the same. It is used to determine the type of the object, that is either base class object or derived class object. So next one is virtual destructors. This is the most important question they will ask in a 2 marks question. Remember, write and explain virtual destructors. Write and explain virtual destructors. So simply the virtual destructor, we know what is a destructor. Destructor is a member function. It is used to destroy the object. Clear? Destructor is a member function. It is used to destroy the object. Destructor member function and class name both are equal, but only the difference. What is the difference between constructor member function and destructor member function? Constructor is a special member function. Destructor is also special member function. Constructor is used to initialization of an object. Then a destructor is used to destroy an object. Simply release a memory. Clear? But here in the destructor member function, prefixed with the negation symbol or tilde symbol. Clear? That is only the difference. The virtual destructors are implemented same as virtual functions. Clear? Same as virtual functions. In constructors and destructors, hierarchy of base and derived classes are constructed, and destructors of derived class and base classes are called when a derived class object addressed by the base class pointer is deleted. Clear? So here in this example, so derived class object constructed using a new operator. Using a new operator. What is a new operator? Here new is a keyword. NEW, new is a keyword. It is used to assign memory to a pointer variable in C++. Like in C language, malloc and calloc functions. So malloc and calloc functions are used to allocate memory to a pointer variable in C language. In C++ language, new operator is there. New is a keyword. It is used to allocate the memory to a pointer variable. Clear? After allocating the memory, the base class pointer object that holds the address of the derived class object. When a base class pointer is destructed using the delete operator. We know new and delete. These two are the special operators in C++. Simply new is a memory allocation operator. D is a memory deallocation operator. Simply release the memory while using delete operator. These two are the keywords in the C++. Then the destructor of the base class and derived class is executed. Clear? Then what are the differences between virtual functions and pure virtual functions? Differences between virtual functions and pure virtual functions. Simply, what is a virtual function? Virtual function is a member function which is declared within a base class and is redefined, simply overridden by a derived class. Clear? When you refer to a derived class object using a pointer or a reference to the base class, we can call a virtual function for that object and executed the derived class version of the function. Already we discussed examples. So then pure virtual functions in C++. A pure virtual function in C++ is a virtual function for which we don't have an implementation, simply defined. So that is the do nothing. Clear? We only declare it. A pure virtual function is declared by assigning 0 in the declaration. Clear? So then, similarities between virtual function and pure virtual function. What are the similarities? These are the concepts of runtime polymorphism. Clear? So here virtual functions. These are the concepts of runtime polymorphism. So prototype, declaration of both the functions remain the same throughout the program. Here first class, base class prototype and derived class prototype are same. The functions cannot be global or static. Clear? The functions cannot be global or static. So these three are the similarities between virtual functions and pure virtual functions. So then these are the differences between virtual and pure virtual functions. A virtual function is a member function. Clear? Member function of the base class which can be redefined by derived class. Clear? A pure virtual pure virtual functions come this side. A pure virtual function is a member function of base class whose only declaration is provided in base class and should be defined in a derived class. Otherwise, derived class also becomes abstract class. Clear? Otherwise, the derived class also becomes abstract class. What is an abstract class? So the class is defined, implemented. So, but we never use it. That is called abstract classes. Clear? So come this side, virtual functions. Class having virtual functions are not abstract. So base class containing pure virtual functions becomes abstract. Clear? So this is the general syntax of virtual functions. This is the general syntax of pure virtual functions. What is the difference? Then the pure virtual functions assigning 0. In virtual functions, then there is no assignment. Clear? In the virtual functions, defining definition is given in the base class. No definition is given in the base class in the pure virtual functions. In the virtual functions, base class having virtual function can be instantiated. Its objects can be made. In the pure virtual functions, base class having pure virtual functions becomes abstract. It cannot be instantiated. Clear? So in the virtual functions, if derived class do not redefine virtual function of base class, clear? Remember, then it does not affect compilation. So in the pure virtual functions, if derived class do not redefine virtual function of base class, then no compilation error. But derived class also becomes abstract just like the base class. So here derived class also defined, but we never use it, then that is called abstract class. Clear? All derived classes may or may not be redefined virtual functions of base class in the virtual functions. All derived classes must be redefined pure virtual functions of base class. Otherwise, derived class also becomes abstract, just like base class. Then these are all the differences between virtual functions and pure virtual functions. Clear all of you? Okay.